So advanced materials are materials that are intentionally synthesized or designed or modified to have a specific function or application. So they can be powders, fluids, biomaterials, films or solids. They can be synthetic like polyester, which is used in a lot of clothing, or they can be highly modified raw materials such as lithium, which is used in most batteries that are in your mobile phone or your computer or increasingly your electric vehicle. Why advanced materials matter? So advanced materials are the basis of all technological developments since the Stone Age. And if you think about the early medieval times, you had the Stone Age, the Bronze Age, the Iron Age. They were all defined by a material. And I'd say now we're in the Silicon Age or the AI age nearly. Advanced materials are the basis of all manufacturing technologies, everything from farming to semiconductor manufacture, to medical devices, to pharmaceuticals, and most consumer goods. They're a massive market. The materials alone, advanced materials, is estimated to be about 90 billion euro by 2028 in terms of market size, but really they underpin a multi-trillion euro market across all of the previously mentioned sectors. And the OECD has forecasted that due to continued population growth and convergence of living standards, the global demand for raw materials is going to rise to 89 gigatons from 2017 to 167 gigatons in 2060. So this has a significant impact both on resource management but also on the environment, because a lot of extraction of materials comes with greenhouse gas emissions. So there's an offset between materials consumption and the impact on the environment, and increasingly there's an emphasis on decoupling materials and resource consumption from economic growth, which is really the basis for most material science research these days. What the EU Commission strategy for European industrial leadership in advanced materials means is the EU has a significant leadership position in materials innovation. 25% of all the patents in the world come out of European innovation, and the region is really strong in terms of academic leadership and early stage research. There's a little bit of a weakness in Europe around the translation of that innovation into commercial use. Partially to do with the fragmentation of the region. Every nation state has its own strategy, but also in terms of the investment of infrastructure that allows companies and public sector to scale those really good materials innovation into something that people are going to use. The strategy is aligned around 5 pillars. The first is around aligning materials research and innovation policy across the member states around specific priorities. And this will become in the form of a European Technology Council for Advanced Materials, which will define the priorities for the region and all the member states. Initially, there's a huge focus on the environment and climate change, semiconductors, transportation and construction. I think it's worth mentioning that it's estimated that about 70% of all the innovations associated with climate change and Green Deal will be attributed to materials, and that's why it's so important. The second pillar is around fast track from lab to fab, which is exactly what it means. It's investing in the technologies that we're going to need to accelerate the innovation out of the labs and into people's hands. This is in 2 ways. First is on the emphasis on AI and machine learning for materials discovery. AI is not immune to material science, and increasingly it's being used to accelerate the innovation, to draw on different data, to look at things like life cycle assessments, and to predict how the material is going to behave in the future. And the second is an investment in hardware infrastructure to help translate those technologies out of a lab environment into pilot scale and eventually into a factory. The third pillar is around increasing capital investment to allow companies, and particularly SMEs, to accelerate their innovations. There will be a 500 million euro investment between 2025 and 2027 on a co-programmed public-private partnership called Innovation Materials for EU. The fourth pillar then is on fostering the production and use of advanced materials through public procurement, through the deployment of standards, and through the Advanced Materials Academy, which is going to really upscale the European ecosystem in terms of materials deployment and use. And then the final pillar is about governance and the European Technology Council, which will be really important for Ireland to be part of. Why is this important for Ireland? Well, first of all, materials is a research priority for Ireland since 2012. This is because of the importance of the manufacturing sector for Ireland. Manufacturing accounts for about 38% of our GDP and 44% of our corporation tax receipts. We have a massive infrastructure here in terms of semiconductor manufacturing through Intel. We have a huge medical devices industry employing over 20,000 people. And we have obviously an agri-tech and food industry, which increasingly is becoming more material centric around some issues associated with the circular economy and plastics. Okay, so why is material science important for Ireland? So material science has been a research priority in Ireland since 2012, and this is largely because we have a large manufacturing sector here in the country. It employs over 270,000 people. It accounts for 38% of our GDP and 44% of our corporation tax receipts. And our manufacturing sector spans everything from semiconductor manufacturing to medtech to pharmaceuticals, and obviously the agri-tech and food sector, which is increasingly material centric because of packaging. Ireland as a small open economy is highly export driven and highly dependent or susceptible to vulnerabilities in global supply chains, which is increasingly becoming relevant with things like the war in Ukraine, with the trade disruptions between the US and China, and in having a competency in material science that we can both work on substitution technologies but also have the understanding to harness things like the circular economy to shore up our supply chains and make our manufacturing and industry more resilient to these types of disruptions is going to be really important. So participation in the EU community on these priorities is going to be critical for Ireland. It's also critical for, obviously, as I said before, climate change and the climate action plan, which is very dependent on things like wind, on the hydrogen economy, on battery technology for the storage of energy, and all of these again are material centric. Everything from how do you recycle wind turbine blades to how do you store the energy that you're going to generate from the wind. It's the biggest problem we have is on energy storage and batteries, to how do you make materials that are suitable for the transportation and storage of hydrogen, which is a very small molecule and leaks out of everything. And so having that competency in material science is really important, not just for our economy but also some of the societal issues associated with climate change. And then finally, with the health sector, we have an increasingly aging population, and a huge amount of material science research is going into keeping people out of hospital, looking at things like regenerative therapies, like assistive technologies to help people stay at home and out of the hospital in the future.